Okay, so to begin this first essay in Unit 4, we're going to talk a little bit about reabsorption. And so I'm going to draw a kidney cell here. And then I'm just going to draw part of one here. And so there's two ways things could be reabsorbed. And so if it goes directly through the cell, we call that transcellular. And if it goes between the cells, it's paracellular. And another important thing is with all these cells is we're going to have this very crucial pump that pumps out 3 sodiums and 2 potassiums with ATP. And so we're going to have that on all these cells. And so to get into the specifics on what's happening during the tubule, we're going to start with the proximal convoluted tubule. And so I'm going to draw a cell. And then partial one. And these are all going to be happening on the same cell here. And then here's the blood. But I'm just going to draw multiple to kind of keep things more organized because it can get a little bit messy. And so first, I'm going to draw this important sodium potassium pump with ATP. And that's going to what kind of pushes everything, kind of is I can't think of the word, but it gets everything started. So sodium's going to come in with all these. And so we're going to have glucose. We're going to have lactate. And we're going to have amino acids come in, all with sodium. And then right in here, for water, we're going to have these aquaporins that push water through. So we got water. And water's also coming through here, and this is what we call a solvent drag. And so this water that's going through, it's going to drag calcium or potassium with it as well. And so to get it back out of the cell, we'll have lactate, and then we're going to have this, I see it's already getting messy, this GLUT2 transporter for glucose as well. And one thing I forgot to mention is this sodium with glucose. This is going to be called our SGLT pump. And so we've talked about a lot of particles and substances that get pushed through, that get reabsorbed by the cell. One that we're forgetting is bicarbonate. And so we have this little equation of H2, sorry, I can't even do this. So water, carbon dioxide goes, and we get bicarbonate and a proton. And this is what we call carbonic anhydrase, or Ca right here. And so that's going to be important. So we're going to have this. So we're going to have H plus and HCO3, this carbonic anhydrase, and then H2O and CO2. Then we have this Ca here. This HCO3 is going to get pumped out with a potassium or sodium. And then here we have this proton with sodium. This is going to come to this carbonic anhydrase. We're going to get HCO3, and then our water and carbon dioxide. So that proximal convoluted tubule, that makes up most of our reabsorption, but we also have proximal straight tubule, for chlorine. And so I'm going to draw another cell here. And then in this cell we have hydrogen and a base. And so we're going to have a hydrogen come out with sodium. And then we're going to have the base come out with sodium. And over here we have a chlorine leak channel called CFTR. And that is how chlorine gets reabsorbed. And one thing that is important to mention is when we're talking about blood glucose, so our blood sugar, it's important that we're within these values. And so normally we have 70 to 180 millimeters. So that's going to be normal. And then our renal threshold is going to be 250. So 250 is our renal threshold. And then once it becomes our 300 is what we call our saturation. And so we never want to reach these levels right here. We really want to be within this 70 to 180 range. And that wraps up reabsorption. Okay, so next in our essay, we're going to talk about filtration. And filtration is the first thing that happens in the kidneys. And it kind of just separates everything in our body. And so we have here our glomerulus. And then we have our Bowman's capsule. So in the glomerulus, we have different types of pressures. So we have 55 hydrostatic pressure, 28 of our BCOP. Then outside of it, we have 10 of our CP. So we have a net filtration rate of approximately 17. And then this portion right in here is what we call our GFR, or our glomerular filtration rate. And one thing I should point out is right here is our filtration membrane. And so there's couple different things. I shouldn't say things. A couple different ways that our kidneys are that our filtration's auto regulated. The first one's myogenic, which increases our blood pressure. One thing I should point out is here, to kind of help maintain the pressure of the kidney, which is super important. Let's say it vasoconstricts right here. That is going to decrease our blood pressure. And so now we'll go back to this auto regulation. So we have myogenic, but the one we really want to focus on is our tubular genular feedback. So this can help with increasing and decreasing our blood pressure. So let's say we decrease blood pressure, that will decrease our filtrate, our NaCl. Then it goes to our macula densa, to our plasma. Then we'll have urodilation, and that will increase our blood pressure. Let's say we have increased blood pressure, that will increase our filtrate to our macula densa, to the ACH, which will vasoconstrict. And like I said, up here, if we vasoconstrict, that will lower our blood pressure. And so that's a little bit about our audio regulation. And so the next thing we need to talk about is clearance. And clearance is very important as it checks the function of our kidneys. And so I'm going to draw here our glomerulus Bowman's capsule again. And then I'm going to draw a little urine cup because we check our clearance through our urine. So up here we have our P of X, which then we have our X, which gets reabsorbed. And then we have our V, and then down here we have our U of X, which X is our substance. So our clearance of X equals our U of X minus V all over our P of X. And so before you would have to pee in a big jug for 24 hours, but there's something that we can do to equal our GFR. So our C of X can equal our GFR if what? So what criteria has to be followed for this to happen? For one, there can't be reabsorption, can't be secreted, has to be freely filtered, can't have any charge, has to be small, can't be metabolized, and it can't be created. And we actually have a substance in our body that follows, as I know doesn't seem that likely, but there is, and that is inulin. And so our C of inulin equals 125 milliliters per minute, which will equal our GFR. But that brings up another substance that is very similar to this value. So we have our C of creatinine, which equals 128 milliliters per minute. And so that can also equal our GFR. And so then we're able to check the functions of our kidneys through this GFR, our value. And that wraps up filtration. Okay, so next we're going to talk a little bit about renin, angiotensin, and aldosterone. And so, to begin, I'm going to draw a brain here. I know my drawings aren't the best. And then we're going to have different types of receptors here. And so this is our baroreceptor, which is going to decrease our frequency. This is our angiotensin 2, and that will release ADH. And then this one is positive. This is our osmolar receptor. And so our osmolarity is 300. Let's say it goes and it's 300, and then through here it gets to like 304. And then we're going to be dehydrated. And then we're also going to have that over there. And then I'm going to talk a little bit about how this affects the lungs and all the different parts of the body. So I'm going to draw lungs here. And then a brain. Our liver. And our kidney. And then we're going to have an adrenal gland. I'm going to draw numbers here that will represent all the little things. And I should draw renin, and that will be released into here. And so let's start up here with the brain. So we're going to have angiotensin, the brain, and that will increase our thirst and our ADH. And so our ADH, this helps water absorption in the kidney. So when we're increasing, we're able to absorb more water. And so if we didn't have ADH, we would pee a lot, very much a day. So now we have our adrenal gland. And then that will aldosterone. And then aldosterone will increase our sodium potassium pump activity, which will create new sodium. And another thing that can affect our aldosterone, which is number 4, will be hyperkalemia. So next we have our number 3, and so we have our sphenic, I don't know how to say it or spell it, arterioles, which will cause vasoconstriction. And then 4, we have vasoconstriction of efferent arterioles. And then another thing to point out is if we have renin and angiotensin, that will produce angiotensin, 1. And then if we have ACE with it, we'll get angiotensin 2, which is up here. And that sums up renin, angiotensin, and aldosterone. Okay, so finally we're going to talk about the urine concentration and the role that the loop of Henle plays in this. So to draw that, I'm just going to draw, actually, whoa. And then break it up into different compartments. And so we're going to have our blood that goes around and then goes back up. And we have our water. So now we'll talk about the different concentrations here. And so it's going to be 300, 400, 500, 600. $300, 400, 500, 600, and so forth. And so if we begin in here, we're going to enter and we're going to have a concentration of 100. Wait. $300, 400, 500, 600, and then that's going to get carried over to 400, 300, 200, 100, and then that's going to go, and that's still going to be 100, 100, 100, 100, and so that is good. And so here we have low volume, high osmolarity. Low volume, high osmolarity. Well, let's say, for example, let's say here, now that this gets changed to 300, so then it gets 300, well, then this is going to rapidly get bigger. So it's going to be 400, 500, 600. And this is what causes dehydration. And so we're going to have a high volume with low osmolarity. And that causes dehydration. And so ADH plays a big role in this because it, like we were talking about before, it holds all that water, reabsorbs it. And so we're able to, if there's more ADH, we're going to pee less. And if less pH, we're going to pee a lot more. And that wraps up this portion of the essay.